On behalf of our team, this is Dr. Arafatur Rahman. Would like to invite all of you to our presentations. The title of our presentation is Daemon, which is a data-driven dynamic clustering algorithm for mitigating adverse economic impact of COVID-19. We are from University Malaysia Pahang. First of all, I would like to highlight the project background. As you know that the COVID-19 is a critical issue all over the world, and in order to mitigate these problems, there are three things can be considered. First of all, vaccinations, however, which is not even done yet, and another one is herd immunity development, which requires proper medical infrastructural support, and the last one is lockdown, which is really practicing all over the world. However, this lockdown has a problem. The traditional lockdown is static and which has adverse economic impact, and also the panic is spreading in the mass people. So in order to solve this problem in this project, we propose a data-driven dynamic clustering framework which will mitigate the adverse economic impact during the COVID-19. So the usability of this product is an individual can get the COVID status in his surroundings, so whether he is in a safe zone or danger zone and how far this territory is, and also the government can get the overview of the current status. It also ensure the medical data security, and also it will mitigate the adverse economic impact. The novelty of this product is we propose a data-driven framework, we also propose a clustering algorithm, and finally we develop a lockdown mobiles app. In terms of commercial aspects, basically the potential market is WHO, the World Health Organizations, and the different health ministry in all over the world. For example, in Malaysia, KKM. The market size is really big, which is worldwide. The market survey, this product is suitable for developed and developing country as it requires infrastructure. In terms of social benefit, we can ensure data security, economic impacts, and public awareness. This is the product architectures where we can see the core telecommunication network. Using that, we can gather the data for the COVID information data from the users. So we can replace it using the social networking infrastructure. For example, in Malaysia, they are using My Sejahteraan apps. So after getting this data, the stakeholders, they are gather this data, and based this data, the dynamic clustering map will be designed, and user can get the current status of the lockdowns, and also the data analytics part will provide a lot of services based on this data. This is the proposed algorithm, where the first part we are highlighting the lockdown clustering information maps based on the affected peoples, and also the number of affected people we can also categorize red zone, yellow zone, and safe zone. So this is the prototype, where the first part is the login phases, and after that this is the main menu, where we have first we'll find the medical checkup, so a lot of hospitals nearby, their informations, and this is the safe zone before. That means what was the safe zone yesterday, and this is the safe zone of today. So we found that the lockdown is a bit shrink because the number of COVID patient decreased. Also, we can find the heat map of the overall status of the COVID informations, and these are some findings. So here basically we are using 42 days informations after MCO, and then what we notice that if we go through the static lockdown, where the entire country is covered by the under the lockdown, whereas through our dynamic clustering approach, we can find that a significant part of the country is not under cover or lockdown. So as a result, it will reduce the economic losses, where we can see in a static case which is zero. In dynamic lockdown case, this is reducing significantly. And also in terms of other utilities, for example, number of military utilization during this lockdown, that also in case of static, which is full 100% military support we need, whereas in the dynamic it is also decreasing. So These are the collaborators who see global telecommunication, technology, IBMCU, and our academic collaborators, Birmingham City University. So this is our achievement. Our paper has been published in a reputed journal, that is Sustainable City Society Impact Factor 5.26. The details of our work will be found in these papers. So that's all from our side. Thank you very much for your attention.